Let's start from the very beginning, where everything is said to be made up of atoms. And due to human curiosity, scientists discovered its structure and behavior that contributes to the discovery of the world's complexity. So let's talk about matter. Matter is anything that occupies space and has mass. Just like the trees that you see, the water that you drink, and the air that causes your airplane to fly. These are all matter. But what's inside your matter? Take for instance a ball. Your ball is composed of very tiny particles that makes your ball a ball, and these particles are called atoms. In your atom, you can find a neutron, which is no charge, your positively charged protons, and your negatively charged electrons. They make up the atom. So how did people around the world view atom through time? It all started from the Greek civilization, from the city-states of Athens, the warriors of Sparta, and the origin of the great philosophers. One of which is Democritus. According to him, all matter is composed of indivisible particles called the atoms, coming from the word atomos, which means indivisible. He proposed that matter could not be divided into smaller pieces, but one philosopher in his time opposed. He was Aristotle. He proposed that matter is composed of only 4 elements, namely air, water, fire, and earth. But through time, John Dalton, an English school teacher who experimented a lot about atoms, proposed the very first atomic theory. He had 1, 2, 3, 4 statements in his theory. He theorized that atoms are indivisible particles, that atoms of the same element are all the same, that atoms of different elements are different, and lastly, compounds form through combining atoms. Then there came Sir Joseph John Thomson, who had a lot of fun playing with cathode rays, which led to the discovery of electrons in 1907. But before that, he made the racine-bond model. According to him, the protons are the dough in the atom bond, while the electrons are the racines embedded inside the bond. And then there's Ernest Rutherford, who bombarded the atom with alpha particles. He said that inside an atom, the neutron and the proton comprises the nucleus at the center. Then, the electrons are moving in a circular motion around the nucleus, which he projected as the planetary model of an atom, comparing the electrons with the planets revolving around the nucleus or the sun. After that was Niels Bohr, stating that the nucleus is surrounded by imaginary orbits, and electrons orbit the nucleus at fixed energies and distances. Electrons are able to jump from one level to another, but not to exist in the space between. Bohr's model was well accepted during his time. However, due to further experiments, it was discovered that electrons simultaneously behave like waves, not being confined at a particular point, which led to the formulation of the uncertainty principle by Werner Heisenberg. According to him, we cannot pinpoint the exact location of electrons inside, because it is impossible to know both the position and velocity of an electron simultaneously. The uncertainty principle led to the modern quantum mechanical model, which was supported by 3 brilliant scientists in history. First is Louis de Broglie, who believed that electrons behave with waves and particles. Then, Werner Heisenberg and his uncertainty principle. And lastly, Erwin Schrödinger, who developed an equation that treated an electron like a wave. This model describes location of electrons through describing its principal energy level, energy sublevel, orbital, and spin, aided with a deeper understanding in chemistry. But one thing is for sure, everything matters, even the smallest particle on Earth, even your neutron, your proton, or electron, because after all, in any models, theories, or assumptions, atoms are what make us all matter.
Created using Powtoon.